All right, so our next speaker is Kang, who will be talking about contracting and vertical control by a dominant platform. You can go ahead.
Perfect, thank you so much. So my name is Ziang, and this paper is called Contracting and Vertical Control by a Dominant Platform. This is co-authored with Muir. So I would like to begin this talk with the following observation, that antitrust authorities are increasingly concerned by the emergence of dominant platforms that operate in both upstream and downstream markets. So what do I mean by both upstream and downstream markets? Well, to fix ideas, let's consider the example of Amazon. So Amazon participates in an upstream market, by which I mean that Amazon supplies an input to upstream sellers. So this input could take the form of payment services. So for example, if Amazon hosts a bunch of sellers on its platform, these sellers might pay through Amazon, the consumers might pay through Amazon, and Amazon might in turn give payments to these sellers. Amazon might also supply distribution services in the sense that Amazon delivers packages from sellers to consumers like you and me. Amazon also participates in the downstream market, by which I mean that Amazon competes with sellers on its own platform. So for instance, Amazon might host a bunch of battery sellers, but Amazon also produces batteries and sells to consumers like you and me in the form of Amazon Basics batteries. And this participation of Amazon in upstream and downstream markets have raised concerns by antitrust authorities. And in particular, antitrust authorities are concerned because they're worried that Amazon might use its upstream market power in some sense to sort of gain a dominant position in the downstream market. And so this conflict of interest is succinctly summarized by this US House Majority Report of 2020, where they write that Amazon's dual role as an operator of its marketplace that hosts third-party sellers and a seller in that same marketplace creates an inherent conflict of interest. So on one hand, this conflict of interest sounds bad, but on the other hand, these concerns are also in stark contrast to the traditional view of vertical control that we have from the industrial organization literature. So what is this traditional view of vertical control? Well, the traditional view of vertical control is that vertical control eliminates double marginalization. So what I mean by this is that without vertical control, so if Amazon just uniformly prices all its upstream sellers, Amazon and upstream sellers each applies a markup to their prices. And so there are two markups, one set by Amazon and the other set by upstream sellers, and this results in deadweight loss to consumers and to society in general. By contrast, in the world with vertical control, Amazon is able to fully extract the surplus of upstream sellers, and it applies a single markup, and this results in less deadweight loss, and so it's socially beneficial for society as a whole. Right, and therefore, according to this traditional view, vertical control is beneficial not only to consumers but also to producers, where we consider producers as the sum of Amazon as well as upstream sellers. One caveat of this traditional view is that it makes the strong assumption about information, so it applies only in a complete information setting, and one might arguably think that full surplus extraction of Amazon from all upstream sellers is unrealistic in this setting. And also, so in order to address this concern in our paper, we examined the implications of vertical control under the setting of incomplete information. And so we really answered two questions in our paper. The first question is about optimal contracting, and the second is about welfare. So first, we characterize optimal contracts between the platform such as Amazon and upstream sellers. And second, we compare welfare, namely total surplus, consumer surplus, producer surplus, where there's under two regimes. So one regime is where there's no vertical control, by which I mean that Amazon uniformly prices upstream sellers. And the second regime is where there's vertical control, namely where Amazon engages in optimal contracting with upstream sellers. And finally, in this paper, we also apply this framework to study antitrust concerns about dominant platforms such as Amazon. So to state the main findings of this paper, let me first state the known results from the traditional industrial organization literature under complete information. So with regards to the contracting problem, it is known that two-part tariffs are optimal and fully extract upstream seller surplus. And with regards to the welfare question, it is known that vertical control increases total output quantity. And so since total output quantity increases, downstream consumer prices decreases, and hence consumer surplus increases. It is also known that vertical control increases joint producer surplus, by which I mean the sum of the platform surplus as well as all the individual upstream seller surplus at every single output quantity. Instead, the results that we obtain under incomplete information in this paper is that more complicated contracts are optimal. So not only do we need two-part tariffs, we need a fully nonlinear contract, and these contracts do not necessarily extract upstream seller surplus, so upstream sellers derive some information rents. With regards to welfare, we show that like the case of complete information, vertical control increases output quantity, and so it increases consumer surplus. But unlike the case of complete information, vertical control does not increase producer surplus at every output quantity. Instead, we show that vertical control increases producer surplus only at the equilibrium quantity. And so the simple takeaway of our results is that regulators must consider the equilibrium effects of policy on contracts. So unlike the case of complete information, where we can just consider consumer surplus and producer surplus separately, here equilibrium effects really matter. So let me jump straight into the model. I would like to illustrate the model through a series of pictures. So you'll see that there are two parts to this picture. In the blue box, that would denote the upstream market. So think of this as the market for e-commerce, payment services, or distribution services as mentioned. And the red box below denotes the downstream market. So think of this as, the downstream market for batteries, for instance. So in the upstream market, we will have a continuum of upstream sellers. These are the individual sellers that list their batteries on Amazon. These sellers have the option to sell through two channels, right? So on the left, they could sell through Amazon. That's the platform channel. And on the right, they also have the option to sell through non-platform channels. So think of this as each individual battery seller has their own website. They could also send packages to individual consumers through USPS or some other alternative distribution service. The platform is going to be different from the non-platform channel. So they're going to differ in the sense that the platform is able to price discriminate upstream sellers. So the platform is able to design a mechanism. This will be denoted by QT, where Q is the allocation function and T is the payment function. The platform is also able to produce its own downstream product. So it's also able to produce its own batteries, and the quantity of that is going to be denoted by Y. By contrast, the non-platform channel is not able to do that. The non-platform channel simply sets a uniform price, and that's going to be denoted by T2. And so upstream sellers will choose how much output to send to sell through each channel. So it's going to sell Q1 through the platform and Q2 to non-platform channels. And finally, what does this look like in the downstream market? Well, so all the supply goes into the downstream market. And so not only does Q1 and Q2 make it to the downstream supply, but also the supply produced by the platform itself. And this translates into a downstream price that consumers face that's given by a function of total quantity, Q1 plus Q2 plus Y. And big P here is going to be the inverse demand function. So that's just going to be sort of mechanically given by this inverse demand function. For the purpose of this talk, I'm just going to show you the simplest possible case where we get interesting results, right? So I'm going to ignore the non-platform channel in this talk. So you should think of this as the case where the platform monopolizes the upstream market. In other words, upstream sellers do not have the option to sell through non-platform channels. Everything has to be channeled through the platform. Okay, so let me give you slightly more detail about upstream sellers. There's a unit mass of upstream sellers. Each of these sellers is distinguished by some efficiency parameter where we denote by, which is denoted by theta. And theta determines their cost function. So their cost function is going to be a quadratic function of the total quantity that seller produces, divided by twice of theta. And the reason why we choose this as our parametrization of the cost function is that this results in a linear supply curve for each upstream seller. So theta here can be interpreted as the gradient of the individual seller's supply curve with respect to price. And we are going to assume that theta is drawn from this distribution big F that has density given by little f supported on this interval. We're going to make regularity assumptions, standard regularity assumptions on this distribution F. So more about the platform. The platform designs a selling mechanism in the upstream market. And here we invoke the revelation principle, and we conclude that it is without loss of generality to restrict attention to direct incentive-compatible mechanisms QT. Q here is the allocation function that maps the reports of individual upstream sellers to the quantity of output that they produce. And T is going to be the payment function that maps reports to per unit payment of the good. Since there's no aggregate uncertainty, these functions, Q and T, are not functions of other upstream sellers' reports of the types. And so the platform provides downstream access, or access to the downstream market at zero marginal cost. Here we denote by theta P, the platform's commonly known efficiency parameter. So everything is going to make the platform look exactly like a seller, right? So the cost function that the platform faces for producing its own output Y is going to be quadratic, and the constant of proportionality is going to be 1/2, twice of theta P. Just to be very clear about the timing of this problem, the platform first commits to the upstream mechanism QT, and it also commits to a downstream level of output that's denoted by Y. Next, upstream sellers choose output Q, and then they each pay the platform access some amount in order to access the downstream market. And finally, the platform upstream sellers and consumers participate in this downstream market. So the first result that we have characterizes optimal contracts. And so the first result states that the optimal total quantity, which is Q total here, Q star total, is determined by this equation. This equation is a simple equation that equates marginal revenue to marginal cost. But the interesting thing here is that marginal cost is proportional to the total quantity produced, and this constant of proportionality is going to be the inverse of the sum of two things. So one is the platform's efficiency parameter theta P, and the second thing is the average of all the other upstream sellers' efficiency parameters, but these efficiency parameters are going to be distorted by this function phi, right? So the standard result of no distortion at the top is going to apply here. So if you look at phi of the highest possible type theta, that's going to give you theta, that's going to return you theta itself. However, the only value of theta where phi of theta is equal to theta is going to be the highest possible type. And in addition, we are able to characterize the optimal quantity that each type of seller and the platform is going to produce. And so the interesting thing here is that it's going to be proportional to the total quantity, and these constants of proportionality depend on phi of theta and theta P respectively. And so the way that we interpret this result is that is through comparison with the complete information setting. So in the complete information setting, this proposition holds with the only thing that you need to change in this proposition in order for it to hold is that phi of theta has to be replaced by theta itself, right? So phi is really just how individual sellers types are going to be distorted through the optimal contract. And under uniform pricing, everything is going to go through, just that phi of theta has to be replaced by theta divided by 2. So using the first result, which characterizes optimal contracts, we look at how this affects welfare comparisons. And so we're going to state this result in two parts. So part A looks at just consumer surplus, and it gives you a complete ranking of consumer surplus under complete information, uniform pricing, as well as incomplete information, right? So this is straightforward. This just says that the vertical control is going to improve consumer surplus, even in the case of incomplete information relative to uniform pricing. And then further, if you have complete information, it's going to give you a subsequent improvement from incomplete information to complete information. The more interesting result, in our opinion, is this second part, which is part B. This ranks producer surplus, which again is the joint surplus between the platform and individual upstream sellers. And so when we are just comparing the case of uniform pricing and complete information alone, we can see that these two functions are ranked for any value of total quantity. That's the first part of this results as stated. But by contrast, when we go to the case of incomplete information, there might be some total quantity Q hat, such that the producer surplus under uniform pricing at Q hat is going to be larger than the producer surplus under incomplete information at Q hat. Nevertheless, we were able to show that at the equilibrium quantities, the producer surplus under incomplete information is going to be higher than the producer surplus under uniform pricing. And so let me give you a bit of intuition about this result. This result shows that there are two effects of vertical control. The first effect is that increases total output production, and so this leads to an increase in consumer surplus. And the second effect is that it changes the allocation of output production between the platform and upstream sellers. And so under complete information, the efficiency of this allocation always improves, but this is no longer true when you move to the case of incomplete information. So the only thing here is that accounting for both effects at the same time, we can show that total surplus nonetheless increases in equilibrium. I'm not able to show you the proof today due to lack of time, but the key idea in our proof is that we have to consider the equilibrium effects of mechanism design. So we do this in the two-step optimization problem. So first of all, we consider the type of the downstream price, the value of the downstream price that we would like to implement. And secondly, we solve this constrained mechanism design problem conditioning on the eventual downstream price. So I'm out of time, and let me conclude. In this paper, we develop a mechanism design framework to understand the effect of incomplete information on vertical control. We show that with incomplete information, we have to account for equilibrium effects. And in the paper, we analyze the more general model where the platform faces competition in the upstream market, and we study a wider range of interesting phenomena, including exclusive dealing, vertical merger, and divestiture. Thank you very much.
All right, we have time for questions. Or virtual questions if there are any. All right, well, thanks to Yang one more time. And that concludes the session, so thanks everyone.